And so here we are. What does a linear differential equation look like? Well, they have a very specific shape to them. It will be the derivative, sometimes called y dashed, dy by dx in this case, plus a function of x times y equals a different function of x. So if you ever get a differential equation that has this shape, it's going to be called a linear differential equation, right? And when it's a linear differential equation, you solve it in a totally different way than variable separable, right? Variable separable, we had the crossover and all that good stuff, right? And you integrated both sides and you eventually fought your way through to y equals if you possibly could. Now we're going to look at how to solve this fella. Well, it's a sort of a formula with integration in it, I guess. This is the formula part. The solution to this differential equation is 1 over I of x, brackets, the integral of I of x qx plus the arbitrary constant c. I of x has a special name. It's called the integrating factor. And look at how you get I of x. It's e to the power of an integral. So there's a lot of mechanics to these questions. There's a kind of step 1, step 2, step 3, step 4 kind of thing. I've just roughly broke them into 3 major stages. The first thing you need to do is to take your differential equation and make sure it has this format. So that pretty much means make dy by dx on its own, then put next to it whatever y's you've got, and then make it equal everything that's left over. And that's going to be your first step, if you need to. If the question's already got that, step 1 doesn't matter. Don't need to do it. Then you go into step 2. You find this fella called the integrating factor. He's like the key to solving it. And that means you have to find e to the integral of whatever this guy is. So that's going to be things like, I don't know, e to the x, e to the log x, things like that. And you're going to be doing a lot of log algebra and exponent algebra very often in step 2. So you find this guy and you make him as simple as possible as step 2. And then basically step 3 is you put all the pieces together, and you can notice that you've still got some integration to do. But when you're finished, you are done. And the nice thing is that there isn't any weird C algebra, because the C just appears there and it's done. Right. So here is an example like question 1. Okay. Derivative, take away 1y equals 4e to the x. That guy is good to go. You see the derivative on its own, so many y's equals what's left over. Now in this case here then, I like to write down who P and Q of X are. Because there's a lot of stuff going on and it's easy to, you know, lose track of who's who. Right. So what I'm now going to do is I'm going to find the integrating factor, essentially step 2. And it's going to be e to the integral of P of X dx. In this case, e to the power of the integral of -1 dx. And this is e to the negative x. We okay with that? Do you notice that there's no plus c's going to happen anywhere except there, right? That's the only plus c. So don't need to worry about adding plus c's here, there, and everywhere. Ignore that. It all gets took up by this guy. Well, that's basically step 2. So let's get the solution. Well, the solution is y equals 1 over the integrating factor times the integral of the integrating factor qx dx odd to C. Now, it depends on how complicated this is, whether I will do this in one go, in other words, just plug all the pieces in and solve it, or whether I take this little bit out and do it as a separate piece of work. And then once I got the answer, I'll return here and just stick that in, right? Depends on what's going on. This one is pretty easy, so I'm just going to do it in situ. So 1 over ix, the integral of ix times qx odd C. Now this fella here combines with that fella there. And what do you get if you take an e to the negative x and you multiply it by an e to the positive x? What do you get if you multiply e to the negative x times e to the positive x?
1.
Yeah, you get e to the 0, which is 1. So that basically means this integral is just 4. Now, what about 1 over e to the negative x? Do you know that's a quite ugly way of writing that? What could I rewrite 1 over e to the negative x to make it look? I would call it e to the x. And now what we've got is pretty much the answer, because isn't the integral of 4, what's the bracket? Just 4x, I'd say. And there is your general solution to your differential equation.
Do you not distribute the e to the x?
I wouldn't say it's wrong to do it, but I think it looks, do you think, I don't know, it looks kind of nice that way. Do you agree? It's kind of more compact as a factored version. So I would probably just leave it.
Like if you did, would the c just stay the same?
Yeah.
Okay.
Yeah, I mean, I personally wouldn't do it, but if you wanted to do it, that is totally fine. I'm sure WebAssign is clever enough to realize that that and that are the same thing. I know, does that look nice? I mean, this is kind of like tasting music. I mean, this is tasting equations. I mean, you might like the look of that. You might think that looks nicer in your brain. I kind of like that one, but whatever. I can see situations where I might do that. Can you imagine that this thing here wasn't 4x, but 4e to the negative x? I probably would have multiplied it through because I think it would have looked nicer in that case. So it depends on the situation. Oh, and by the way, that's step 3. Now, that's a very straightforward one, but it does give you the process. You get a feel for how this is going to work now, right? So that's question 1. Here's question 2. Now, it has a little bit of work to do. This is how it has to look. This is what it looks like right now. There's not a lot of movement, but would you agree there is something that has to get changed? It has to be changed a little bit so that it looks like this, especially there, right? And what's the problem? Well, what I see is that negative y on the right-hand side should be over here, shouldn't it? So if I just add y to both sides, we get that. Everything so far so good. Now, in this particular situation then, p of x is 1, and q of x is 7x. Okay, that's me, got those two guys. So that is step 1. Now, step 2 is get the integration factor. And that's e to the power of the integral, p of x. And that's going to be e to the number 1. And that's just going to be e to the x. Agreed? Now let's see then what the solution looks like. One over the integrating factor. The integral of the integrating factor times q of x dx, I'd say. Now, this is going to be 1 over e to the x. The integral of e to the x times 7x. And that is just tidying up a little bit. I won't call this a problem. That's a funny little mark. It's just still one. I wouldn't call this a problem, but I would call it that something we have to fix. Don't I have to integrate this? Now, I don't think just because I'm lazy, I don't want to have to write all the other stuff next to it as I go through it. So I'm going to do a little side job. Oops. I'm going to find out what that is over here. And then on the next line, I'll put it in, add C, right? So that's just to save me a whole load of writing. So at the side here, I have the integral of 7x e to the x dx. So depends on the question. It could be a u-sub. It could be an integration by parts. That's the most likely two that I think you're going to see in these questions. I mean, if it was a power rule, I probably would have just done the thing and wrote it down over here, right? I could have done it in my head if it was a power rule. So what do you think is going to happen in this question? What method?
Integration by parts.
Okay, so now we have to decide who is the F and who is the G, right? So which one of those, I would split it as a 7x and an e to the x. So which one of those is going to be the F?
7x.
Correct. You want to tell us why, Ripken? Why is it 7x? What made you decide that?
That was Jason.
Oh, sorry.
Okay.
I'm going by your sound of your voice, not by anything else. So I don't actually get...
It gets simplified when you take the derivative.
Correct. Okay. So that's one of the kind of ways you do it, isn't it? There are other ways to decide. If you can't integrate it, don't you make it the F? So if the two pieces, if one of them you can't integrate it, that's your F. So in this case, it's F big G, take away F dashed big G d of x. And what do we have? Leave that alone. Integrate e to the x is easy. You just get e to the x. Take away the derivative, well, that guy gets you 7, and you integrate e to the x, you still get e to the x. And if you integrate that, you get that fella. And that guy goes there. Now we have to look at style points. I think I can make this prettier. And I'm going to call this fella e to the negative x. And the reason I'm going to do that is that I can now distribute through it. Now, if you multiply this fella here by this guy here, you get 7x. If you multiply this guy here by this guy here, you get -7. And you multiply this guy here by this guy here, you get c e to the -x. And I would say that that is a nicer version, style point wise. You're happy about an e and an -e, an e to the x and an e to the -x getting you 1, essentially. And so that makes this go away, and that makes this go away, and that guy just kind of gets it. Any questions about that particular one? Are we good? If we're good then. Here's one like question 3 in the homework. Okay, that's what it should end up looking like. That's what the guy looks like right now. Tell me what to do. Make it work. What can I do to both sides to make that happen? And that's the problem, isn't it, the x? I want that x to go away. Typically, as long as you do it to both sides, it's okay. So what could I divide both sides by to make that x go away?
X.
Right. Now, if you divide it by x, you get that guy. Okay, dividing this guy by x is not very nice. You get that. The worst one is going to be this fella. If you take that guy and divide him by x, if you turn them into x to the half over x, you end up with a really ugly looking 8x to the -1/2. Are you happy about what each piece looks like if you divide them by x? That's the only one that actually improved. That one got ugly and this one got really ugly. But that's okay. We have to do it, so we do it. Now, in the format that it's in, derivative, something y equals what's left. So it's got the right shape. In this case, the p of x is 1 over x, and the q of x is that one. Why didn't I rewrite this guy as 8 over the square root of x, which is what he would have looked like if I tried to make him a little bit prettier? Why have I left him in this rather awkward 8x to the -1/2 format?
You need to integrate it.
Yeah. And when you know you're going to integrate it anyway, isn't it a good idea to make it fractional powers, even if those fractional powers are -1/2, right? You just got to bite the bullet. Okay, that's step 1 done. I'm looking at the integrating factor. That's step 2. It's e to the integral of p of x dx, e to the integral of 1 over x dx. Isn't the integral of 1 over x just the natural log of x? And hopefully, you will notice something. If you don't, you're going to have a lot of trouble with this question. Style points, right? Making things look pretty. That guy is actually really pretty, isn't he? What is that guy?
X?
Yeah. So we can now move into step 3. And step 3 is the solution. 1 over the integration factor, the integral of the integration factor q plus a c. And that's going to be 1 over x, the integral of 1 over x times 8x to the negative a half dx add c. Okay, and that might look horrendous, but I don't think it's going to be horrendous. What I'm going to do right now is figure out how to make that look pretty. Essentially, haven't you got x to the negative 1 multiplied by an x to the negative a half? You agree? X to the negative 1.
Why would the I of x become 1 over x when we solved that I of x, which is x?
Because the formula is 1 over I of x, so 1 over x.
Yeah, but in the integral part, you have it as
Oh.
1 over x.
That's because I made a mistake. Well caught. So we have x, same kind of argument, slightly different result. Isn't that like x to the 1 multiplied by x to the negative a half? Now, if you put those together, and don't you end up with 8x to the positive 1/2? Are we good? Right. Now, power rule. Add 1 to the power. Divide by the new power is like multiplying by 2/3. So I guess I'm going to get 16/3 plus c. I'm thinking style points here. I think it would be worth it to distribute this one again. Now, 1 over x times this essentially subtracts a power from it. So you get x to the half. And this times this, I could call it cx. And this guy here, I think he looks prettier like that. So that is the prettiest version I can think of to the general solution to the differential equation. Now, I can't guarantee this. You'll probably tell me, not tomorrow, hopefully, some of you do it. WebAssign might say, yep, I'm happy. WebAssign might say, I'm happy. WebAssign might say, I'm happy. It might say, I like all three. It might be really pernickety and only choose one of them, or 2 out of the 3. There's no rhyme or reason in my brain why WebAssign sometimes is really generous and sometimes is fussy, right? Have you ever done that with your homework where it works and then you have to do a different flavor of the same answer just to make WebAssign happy, right? So that would work fine for me. Are we good so far with this question? Any problems so far? It has a nice process, doesn't it? It has a kind of step 1, 2, 3 to it. Fair amount of algebra and not an unsubstantial amount of integration to do. Okay, let me pick something scary. I have no idea what the answer to this is, but it looks scary, so I'm picking it. This is question 6. I mean, that looks scary, doesn't it?
Yep.
Yeah, that's what caught my eye. Some bits of it are not that bad. For starters, isn't this equation good to go? I don't need to do anything. So that's some. The p of x is this guy, so it's 2. And the q of x is that really ugly sine function. My integrating factor is e to the integral of p of x, which is e to the integral of 2. Oh, I see what's happening. It's that guy. So my solution, which is this fella, one over e to the 2x. The integral of e to the 2x times 4 times that guy plus c. I'm not going to do this question much further. Right, that's the last piece of the puzzle, right? Once I get what that is, I've got the answer. That might look really scary, but it's actually not that hard to do. What technique will I use to find this integral? Which I would probably do at the side if I was going to do the question.
U sub
And who is the u sub going to be, Matthew?
e to the 2x.
We are cooking, aren't we? I believe it turns into 2 sine u when you're finished. So it's pretty nice. So, ... Okay, let's go hunting for something scarier then. Whoa, didn't take long. If you thought that was scary, have a look at this thing. Are you suitably scared? Yikes. Okay, but you're not actually going to solve this question. This is set up what the answer would look like question. So they only take like half the way through and you stop and they give you 5 to choose from. So is this guy good to go, or will I have to fix it algebraically? Does this guy look like he's ready to be used, or do I need to do stuff?
Divide by
Do
sine x.
stuff.
I hear divide by sine x, so let's do that. If you divide that guy, you get this fella. I'll just write him down like that. And this fella here, you get that. Okay, now that gives me an, oops, that gives me a p of x equal to this fella, and a q of x equal to that fella. So now I'll do my integrating factor. E to the integral of p of x. E to the integral of cos x over sine x dx. Now, this is not a one-line deal, right? Would you agree that you have a fair amount of work to solve this. What technique will I use? And I'm only focusing on this bit right now. What technique do I use just to find that bit there?
Trig sub?
Do you mean like an X sub? Or do you mean a U sub that has a trig in it?
I confuse myself.
Okay.
Could you write that as cotangent?
Oh, you could write it as a cotangent, but I wouldn't in this question. I would do a U sub. And what U sub should you choose?
Sine?
Sine of x.
Yeah. Now, if you differentiate this with respect to x, you will get cosine x. You then do your crossover, and then you isolate the dx. So this will become cosine x over u with a 1 over cosine x du, which ends up being a very nice simple integral, which gets me the natural log of u, which becomes the natural log of sine x. So far, so good. Which means that this fella is e to the natural log of sine x. And I can make that pretty. E to the natural log of sine x simplifies down to something else, doesn't it? What does e to the natural log of sine x simplify down to?
Sin x.
Sin x. So our solution is 1 over I of x, the integral of I of x, qx dx, add c, and that ends up being 1 over sine x, the integral of that guy over sine x dx, add c. And one of your 5 choices is that guy. And I believe, at least in my one, it's the third dot.
What about wait, could you show the answer again?
Can I show what?
The answer.
This is the answer.
Where is p of x in the integral?
Where is p? Oh, p of x is here.
I meant like in the answer.
I'm confused.
Your answer, like you wrote I of x instead of p of x.
But right, my I of x is here.
Oh, sorry.
All I've done is I've stuck. I could have, I guess, called it 1 over sine x, the sine of x squared, but it seems less work.
I like messed the formula up. Sorry.
Are you good?
Mm-hmm.
Okay.
No,
No.
not good.
What
No.
was that?
I'm
Emma?
confused now.
See what you just did there, Matthew?
Can
Shame on you.
you move the sheet up just tiny bit?
There.
Yeah, that's great. Okay.
You okay then?
I think you're missing
The I
I of x. Yeah, in your
in
answer.
last line.
Oh, he says I'm missing my I of x in my
Okay,
answer.
well,
Right, my I of x is here, and that's it there. Okay. do this again. So our formula is the integral of I of x, q of x, dx, add c. We already found up here, after a fair amount of work, the I of x just ends up being that guy. So my answer will be 1 over the sine of x, the integral of 1 over sine of x, q of x, which is that guy,
And then it'd just be sine x.
and no, oh, I see what you're doing. Sine x squared does not cancel with sine x.
But I of x is sine x, and then q of x is 9 sine x squared over sine x. So then
Yeah,
when those
no,
cancel,
it's not the same thing.
But inside
That-
the
I
integral.
think what he's
It's
saying
inside, exactly.
is that in
but so
Q
that's
of x
that's
is
q
over
of
sine
x,
x.
and then
so the sine
P
x.
of
This is
cancels
q
out.
of x. This here is I of x. And this piece here is the q of x.
But I of x is equal to just sine of x, isn't it? Because in the outside the integral we
Yes.
have 1 over I of x.
Oh,
so that's how we
God,
get the
I
one.
see
Yes,
what
the
you're saying.
Sine of, yeah.
I did that mistake. Yes, darn it, sorry. You're all trying to tell me and I'm not listening. I did that earlier, didn't I? Because this 1 over thing made me think it's 1 over in the original. I gotcha. I was trying to think that you were wanting to cancel this with that, which you aren't allowed to do, but that's not what you were telling me. Yeah, are you unconfused now?
Yes, except your q of x is actually sine x squared over sine x, right?
Yeah, so the sine x.
It
will
is.
cancel
Yeah.
out.
Okay. There we go. And then your sines will cancel.
Which is allowed. God, that one shouldn't have been as hard as I made it. But the fact you all found my mistakes is good because it means you know what the heck you're doing now. Right. I will try and be careful for our last one. So I think we're getting pretty close to the end of these, aren't we? So which horrible one that's left shall I do? Okay, the last one I'm going to do is question 10. And it's x squared y dashed plus 2xy equals 15 cos squared x. This needs to be separated. This needs to be left on its own. So I'm going to divide everybody by x squared. So I'm going to get that. This guy gets you that. And this guy gets you that. Checking I didn't do anything. Here we go. Anything wrong? So P of x is 2 over x. Q of x is 15 over x squared cos squared. And I'll try and remember to use that Q of x the next time. So our integrating factor is e to the integral P of x, e to the integral 2 over x, e to the 2 log x. Ah, be careful here. Be very careful. I want to make this thing pretty. And the answer is not 2x.
Could you write it as e squared times e to the natural log of x?
You could, or you could also do that, which would get you the same effect.
Oh,
And that would be x squared. Are you all happy about why that's an x squared and not a 2x? Right, so we now know the integrating factor. Try and put boxes around it so I don't scan somewhere else. So solution, 1 over the integrating factor, the integral of I of x, q of x, d of x, add c. And that's 1 over x squared, the integral of I of x, which is this ugly looking guy, so x squared times this guy, and then something really pretty happens. It ends up just being 15 cos squareds, because this x squared, which is I of x, cancels out with this x squared here, and they go away, which we like. I don't have time to finish this, but I will take you maybe one more step. Don't we need to find this fella here? It's not going to work with a U sub, and it's not going to work with an integration by parts. We have to realize that cos squared x has an identity that means I can turn it into something else. Any idea what cos squared x should turn into? Sometimes double angle formula is the name we use. Cos squared x.
1/2 times 1 plus cosine of 2x.
What a memory. You get the prize. And since there's 15 of them, can I just stick a 15 at the top? So that's the guy that you're going to integrate. And yeah, it's a bit messy and you'll get an answer. And then, yeah, no, I don't know if in this case, if I want to multiply through by 1 over x squared. I think it's pretty ugly no matter which version you decide to stay with. I just noticed there, so I'll share a comment. You know, I never let anything in my head because I have a poor filter. How good yous were today at number 1, finding my mistake, and number 2, sticking to your guns. Because there could be easy, no, maybe I'm wrong, maybe that's right, and I just didn't get it. But you didn't, and you stuck to your guns. It's really cool to see that, because you're beginning to get confident in what you know to be right. And even if I screw it up, you still know I'm wrong, and you're willing to argue about it. And that was a good moment. Funny that I should enjoy moments where I screw up. But I don't mind that. I mean, it tells me that you're learning it. It tells me that you're doing it. And you're not just a robot writing down whatever I write down and you don't know what the heck I'm doing. You're just writing it down because I'm writing it down. So that was good. That means you're thinking about it. So keep that up. Now, occasionally you're going to argue with me and you're wrong. I mean, that doesn't happen that often, I'll agree. 9 times out of 10, I made the mistake, but occasionally it's the other way around. And don't feel bad about that. That's just life, right? I'm okay when that happens as well. So I don't go home and I turn to my wife and say, those bloody students spent 5 minutes arguing over some and I was right all the time. And I don't do that. So we are done. So you might think, what's left? Just one thing. Out of all the questions I've done today, solving linear, what's the only thing I haven't done yet?
Found a particular
Z.
solution.
Find a particular solution, find a Z. Which is, guess what? Tomorrow. Okay, say hi everybody, and I'll hang about for 5 or so minutes. Anybody has questions?